Hello and welcome to our 5 o'clock press conference, Water World, Historic Floods, Sea Level Rise, Storm Surge, and Climate Change. Our speakers are Ben Vanderplume, University of Michigan, Scott Hagen, Louisiana State University Center for Coastal Resiliency, Davina Passeri, U.S. Geological Survey Coastal and Marine Science Center, and Robert Nichols from the University of Southampton.
All right, good afternoon, late afternoon. My name is Ben van der Pluim. I'm the editor-in-chief of one of AGU's journals. It's called Earth's Future, and I want to just say a couple of words about the journal because the set of topics that we're going to discuss really try to emphasize connections with what the journal does. Because as it shows up there, I'm not going to read it from there, you can read that, but it's an open access science journal that really is trying to understand the state of the planet, but particularly its connections with the inhabitants of the planet, us, but also the general ecosystems. And in doing so, tries to understand something about the future, making predictions of what our future might look like together. It looks both in regional and global scale challenges, and it particularly recognizes the point, which will come up today in the presentations as well, that humans, of course, are major drivers now of the environment, demand for resources, and of the ecosystems. And so what we try to do, just like the set of papers that we'll talk about today, is emphasize that interconnection between the social, the physical, and the ecological system. And the aim for that is to inform you, researchers, policymakers, and the like. So to set up the topic of this afternoon, this session this afternoon, you must be aware, of course, that global warming is resulting in the melting of Arctic ice. It results in the melting of mountain glaciers, and it results in the melting of ice caps, for example, Greenland. And especially the latter is very important to understand because that is the ice cap melting, that contributes significant volumes of water to the oceans, which then ultimately leads to this issue of sea level rise, which is what we're going to focus on. And in this century, the 21st century, we should anticipate an order of about 1 meter or so of sea level rise. That doesn't sound like much, given that on the whole we're about 1.5 meters, 1.80 meters in height. But what we are talking about is the lives of hundreds of millions of people is going to be very intimately affected by this change. 1 meter sea level rise will have an enormous impact on today's human society. And the reason is living on coastal areas and living in low-lying lands. The other thing that is really important to be aware of is not just sea level rise to understand as its sheer elevation, but also that sea level rise has a major impact on the results of storms that are making land. And why that matters is that when storms come to land, they actually pull up the sea level just a little bit more. We call that storm surges. So as you talk about a sea level rise of 1 meter, you might consider storm surges are amplified on top of that. And so we also are concerned about these issues related to storms in coastal and low-lying areas. And frankly, if you follow the news, which I'm sure all you guys do for sure, you've seen impacts of of those coastal processes in the last few years, even in the United States. And you've also noticed that we're not particularly resilient to those impacts. So to recognize the importance of this topic, Earth's Future has published a set of papers, and rest assured, I just put them up there so that they're up there. I'm not going to talk paper by paper, but there's a whole set of papers that examines this key aspect of sea level rise. And what is particularly important is it tries to take a novel approach, an integrated modeling approach to understand our future much better than before. It tries to think about feedbacks that are taking place, the importance of those feedbacks among the physical, the biological, and the social processes that take place. And the reason why it does that, it probably will lead us better to understand and to make decisions toward upcoming environmental change, and particularly impacts. And the goal of understanding that is to try to enhance the resilience of human society in a changing environment. These are the introductory words I just wanted to make to give you the framework. My colleagues on the panel will emphasize aspects of that, and then after that we are available, of course, for questions on topics related to that. Scott.
Thank you, Ben. And I want to thank Ben for his support of the special issue that we published. That collection of 10 manuscripts into 10 journal articles is just a fraction of the publications that have come out of a project that I have had the privilege of serving as the PI on for the last 6 years. It is funded by NOAA, and we've been looking at the ecological effects of sea level rise in the northern Gulf of Mexico. As a result of that study, I would like to communicate, if I'm successful, some basic principles that are associated with the study. One of those is this consideration of a bathtub model. And if you look at the bottom of this slide, you'll see the northern Gulf of Mexico spanning Louisiana, Mississippi, Alabama, and the Florida Panhandle. This is the coastal land margin. What's in color down there is representing the floodplain and the Gulf of Mexico and the transition in between the two. And I think particularly when you focus in on Louisiana, with all of the press that we have seen on coastal Louisiana and the land loss in coastal Louisiana, we can all appreciate that as the sea level rises, the coast doesn't stay the same. And so when we began this project nearly 6 years ago, we were trying to shift the paradigm of how these types of analyses could be done, how we could better assess sea level rise at that coastal land margin. And one of the things that we considered is what's going to happen at that coastal land margin with the rising sea level. If you think in terms of a salt marsh, there really are a lot of coastal dynamics that are going on there. First of all, the nearshore profile is likely to change because as the sea level rises, waves are able to penetrate closer to the shore. They erode away the shore, they change that nearshore profile, and more pressure is put on the coastal marsh. When the coastal marsh is driven to the upland areas, it is likely to encounter freshwater species, in this case, a coastal forest, and saltwater intrusion can happen, and a freshwater species is likely to die out. So we wanted to develop an integrated modeling system that would be able to describe such features. And this is the bare essence of the difference between a bathtub model and an approach that takes into account the coastal dynamics of sea level rise. It's that recognition that we're projecting something that's likely to be 50 or 100 years into the future. And 50 or 100 years into the future, the system is going to change, and it will likely change dramatically. So we developed a tool, we call it HydroMem. It's a hydrodynamic marsh equilibrium model. The bottom line with this is it's a model that allows us to project the evolution of a salt marsh with time. So if you look at the graphic, the cartoon that's being animated, you'll see the year in the upper right-hand corner. And you'll see the conversion of this marsh system with sea level rise. In this particular case, a sea level rise of 2 meters by the year 2100, and how much of that marsh is converted to open water. When that marsh is converted to open water, then what we can consider is that hurricane storm surge can move more freely, more further into that coastal land margin. There's more surface area for the wind to blow over and to drive surge up through this region. And knowing what's happening at these salt marsh regions, these important estuaries, is really important for us to understand the ecosystem impacts of sea level rise in general and climate change. We can take this conceptualization to a hurricane storm surge concept as well. So we have some infrastructure that's along the coast, and we have a rising sea. And again, the waves penetrate further inland, and understand we're projecting something over a very long period of time, over a 50 or 100-year period. So a century from now, will the coast still be as it is today? In our experience, our anecdotal experience over the last century is that no, indeed, it will not. Not unless we engineer structures along it or unless we help the natural system to maintain itself. Another point that I would like to make that comes out of this special issue that we put together and the research that we've been doing over the last 6 years is that we really shouldn't just think about assessing the impacts of sea level rise. We should recognize that sea level rise is tied back to carbon emission scenarios. So with carbon emission scenarios, what we can begin to evaluate if we have projections, for example, here of future land use, land cover, is that under a different temperature rise, we're going to have a different resulting sea level rise. The higher the temperature rise, more glacier melt that we're going to have, more thermal expansion of the coastal oceans, of the world's oceans that we'll have, the more sea level rise that we'll have, the more impact that we'll have to the plant communities throughout the system. And again, when we think of the year 2100, when we're going that far into the future, we have to understand that population is going to continue to grow. And unless something very dramatic happens, people are going to want to continue to live along the coast. So these areas that are represented in red that are developed are going to continue to grow, and we must represent them in our integrated modeling systems. And so we've taken that into account when we've made projections of future floodplains. And here I'm showing you the 1% probability still water extent. And as an example, what I can tell you is that this is going to increase the amount of agricultural area that's impacted. And under the high sea level rise scenario, under 2 meter sea level rise by the year 2100, it will potentially result in damages of about $280 million just to agricultural lands alone. I'm not going to read through all of these major takeaways. They'll be made available to you, and I'm happy to meet with any of you at a later date or what have you, and answer questions now. And at this point in time, I'd like to turn it over to one of my colleagues, and Davina will continue.
All right, so I'm going to talk a little bit about the effects of sea level rise in the context of the coastal landscape and also astronomic tides. So we know that the coast continuously evolves, and so to predict these long-term coastal changes, we can use statistical models that are trained with observed data. So this can be information like historic rates of sea level rise, information about the wave and tide climate, and also the geological characteristics of the barrier island or the beach. So in the northern Gulf of Mexico, we found that under increased rates of sea level rise, shorelines were projected to become increasingly erosional, and dune heights were projected to decrease. The figure to the right shows the projected shoreline position in Santa Rosa, Florida, under 20 centimeters of sea level rise, which is the solid red line, and then under 1.2 meters of sea level rise, which is the dashed red line. This is on top of the present-day aerial imagery. So these types of projections can be useful for coastal management decision-making and also in coastal studies. Identifying erosion risks along the coastline can help establish monitoring, stabilization, or beach nourishment projects that can reduce future erosion. And also these projections can be used in tide and storm surge assessments of sea level rise, which is what Scott was just talking about. So we wanted to see how the astronomic tides would change under sea level rise. So these are the tides that are generated from the gravitational pull of the sun and the moon on the Earth. So using numerical models, we simulated tides under different sea level rise scenarios and included projections of our future shoreline position and also our dune heights. We found that within our northern Gulf of Mexico study area, that the tide range was projected to increase within bay systems. So the largest increase we saw was about 67% from the present day under the 2 meters of sea level rise scenario. And this is important because tide range governs salt marsh productivity. So with an increase in tide range, that leads to more inundation. So that might help a salt marsh by contributing additional sediment, or it could harm a salt marsh if there's too much inundation and the marsh drowns, which is what you were seeing in those figures that Scott showed. We also found that the tidal velocities were projected to increase in our estuary systems. So in Grand Bay, Mississippi, our tidal velocities actually doubled under our 2 meters of sea level rise scenario. This could negatively affect oyster recruitment and also lead to marsh edge erosion. We found that the tidal currents may be stronger on the ebb tide or the outgoing tide, which could alter sediment transport patterns and reduce the amount of sediment and nutrients to seagrass beds and to marshes. And lastly, we found that the tidal inundation was projected to increase in the floodplain. So the figure to the right is the projected high tide inundation in Apalachicola, Florida. The blue is the present day, and the orange is under 2 meters of sea level rise. So what you can see is that we're getting increased inundation along our barrier islands and also in the low-lying lands, especially in the marshes. So these kinds of results are important for infrastructure planning. Areas prone to increased inundation might be prohibited from future development. And also we can use these from future mitigation strategies, so beach nourishment along our barrier islands to help prevent this future tidal inundation. We can also think about the coastal change due to storms and sea level rise. So barrier islands are vulnerable to extreme morphologic changes during storm events, and sea level rise can exacerbate this. So again, using numerical models, we can simulate the barrier island response to storms and sea level rise. For example, we wanted to see what would happen if Hurricane Ivan hit under 2 meters of sea level rise at Dauphin Island, Alabama, which is a barrier island right off the Alabama coast. We found that the island would be completely inundated with storm surge. So in comparison, when Ivan hit in 2004, this was about a 10% increase in inundation. We also found that there'd be extensive dune erosion across the island, especially in the low-lying areas. About a fifth of the dunes would be completely wiped out. And again, in comparison to 2004, there was dune erosion, but none of the dunes were completely lost. So these assessments are essential for looking at the future loss of property, infrastructure, and habitat, and also potential mitigation strategies like using natural and nature-based features. So for example, if we build our dunes higher and wider, that might prevent inundation and erosion. So the takeaways from this are that the effects of sea level rise are dynamic and interrelated. Increased rates of sea level rise can result in more shoreline and dune erosion in both short and long time scales. We saw that there were increases in the tide range, tidal velocities, and tidal inundation under different sea level rise scenarios. And these results have implications for natural and built coastal environments. So we really need these integrated assessments that consider the different dynamic effects of sea level rise to provide more comprehensive evaluations that will lead to more informed coastal management decision-making and ultimately will produce coastal resiliency. So with that, I will hand it off to Robert.
I just wanted to step in real quick and point out that the work that we've done has been focused again on the northern Gulf of Mexico, and we've put a lot of effort into Mississippi, Alabama, and the Florida Panhandle. And the work that we've done has funded and supported 3 PhD students, one of which was Dr. Passeri. And I think what you can all appreciate is that our future is in really good hands when we have people like her and like Dr. Bilski and Dr. Alizad, who are in the audience as well. This is how we support the future of science with projects like this. But I also wanted to recognize it's my honor and privilege to introduce Robert Nichols. He is joining us from the University of Southampton, and he's one of the leading coastal engineers in the world today. I was very pleased when he accepted our offer to join this. And he can speak about these same types of issues. He's been doing this similar type of work only on a global basis. So Robert, thank you for being here.
Well, thank you. It's a great pleasure to be here. And I want to take that, maybe get that global perspective and go back to what Ben said, remembering that this is a global phenomenon. It's happening around the world's coast. And say there are 600 million people living below 10 meters elevation today, or more than 600 million people in the low elevation coastal zone, to give a sort of scale. Those people directly or indirectly affected by sea level rise. 130 plus cities of more than a million people on the coast. All the world's deltas, by sort of definition, well, maybe not all the world's deltas, but most of the world's deltas, except those on lakes, where all the people live, small islands, etc. Lots and lots of vulnerable areas. And what does this kind of work mean? Well, I think let's go to one of the hotspots. Bangladesh, I think, is widely recognized as being one of the most vulnerable places on Earth to sea level rise. And this kind of bathtub view, it's simply looking at the elevation contour, has been around since the 1980s and is still available on the web. I just downloaded it fairly recently, and sort of showing you that in the lower panel, with 1.5 meters of sea level rise using the contour, you have a loss of 22,000 square kilometers of land, 16% of the country, and 17 million people live there. So the implication being 17 million people are being displaced. But then we've been working in Bangladesh and sort of doing some much more detailed work. And you start thinking, well, what's actually shaping coastal Bangladesh? And there are sort of drivers at different sorts of scales. So we've got sort of the global scale, the sea level rise, etc. we're talking about. But then we move down, we have regional issues. The rivers that produce the sediments that make the delta are really important. The Bay of Bengal as well, that's where storms come from. The river delta itself, where people live, and there's lots of things happening there, how people, they've built, for one example, polders, lots of dikes which regulate how water moves across the landscape. And then that really affects the delta communities. So to really understand how this might be impacted by sea level rise, or other kinds of change, because other things could matter there as well, you really need to understand all these different scales and how they interact. And that's what we've been doing in a big project led by the University of Southampton, but with many partners, more than 100 different scientists in 3 countries, UK, Bangladesh, and India, working on it. And this is the kind of picture that you get if you simply take that analysis and actually look at what might be flooded with a 1.5 meter sea level rise by 2100, taking into account what we're seeing on the ground, particularly the polders and the dikes. And the darker the area is, the more of that, the higher percentage of that area that's flooded. And you can see that it's actually a rather different picture from the sort of bathtub view. You could easily flood this much more. There are no cyclones being considered here. So, this is just one realization of what might happen. There's a lot of different pathways we can see here. But the point is, you're getting a much richer picture and a much more detailed picture about what might happen as you start to include all the complexity I just talked about. And we can move on. And here's a pair of images that sort of show in the show here. Let's imagine we have the dikes as designed. Let's imagine here they actually aren't working quite as well as we planned, not maintaining them. And you can see the colors are getting darker. So as well as just looking at sea level rise, we can also start to think about how well our interventions are influencing things. And within this framework, down here, this is the Sundarbans. So these are the largest mangrove forest in the world. We can also think about the effectiveness of the mangroves as a buffer against sea level rise and storm surge. So we can bring in a whole host of different things, and we can start to think how they fit together. And the Bangladesh Delta Plan 2100 is actually thinking about the whole country and its future up to 2100, as its name would suggest. And we've been working with them as part part of this project, and certainly they are very interested in the detailed kinds of information that these kinds of analyses can bring, the richness that we can look at, rather than just looking at like cost benefit, which is often the criteria for making decisions. We can look at a lot of different indicators and think through what different trajectories might actually mean for Bangladesh. And so I think this kind of approach shows a methodology where you can really inform government and empower them to make decisions that manage problems like sea level rise and for the betterment of the country. Thank you.
Okay, thank you. We'll now take questions from any reporters who are in the room. Please state your name and affiliation. Do we have any questions from reporters in the room? No questions? Do we have any questions from the chat? No? Okay. Again, any questions? Okay, we have one over there. Wait. Actually, we have people on the website.
My name is Katrin Weiss, and I'm from Earth Rocks. So I can't help but ask a follow-up on that last comment about empowering governments who want to be able to create plans for their country in the future as sea level rises, and how that might look in the United States, especially considering the incoming President-elect.
Well, I think it's a fair question, and I think it is something that we all have considered to some extent. But I think if you take a detailed look at the kind of work that we're doing and the basis that we're providing, it's really for an economic analysis. Really, in hard terms, what it's all about is understanding what is the economic benefit at that coastal land margin. What are the ecosystem services valuations, if you will? So when you go to Apalachicola, if you're out on the bay, what is the value of that bay? What is the value of the expansive marsh that surrounds it? And we are now at a position where we can work with people who are experts on that, and we are. And Dr. Nichols is at Bangladesh and at other locations. And we can evaluate then trade-offs between economic damages that are caused by storm surge, for example. And if the marsh is lost and if the bay becomes larger and we have more storm surge penetrating through that area and it's impacting higher up into the coastal floodplain, then we can put a number to that. And I think this kind of mentality is something that is appreciated by any policymaker. It's something that can be appreciated by anyone regardless of their political leanings.
If I follow up, I mean, I think coastal areas are very important, and so therefore this kind of approach provides a sort of science-based information source for making decisions. I think that, and so building up this kind of capacity is really important. I think also the timescales of developing these capacities are also quite long. So I mean, I've been working on this issue for a few decades now. So, and we're getting better at doing it, and I think we're going to continue to do so. So, so I think the timescales of improvement here are also measured in decades.
I'll follow up on that too. So as a federal employee, now's the time that we really want to showcase the research that we're doing and show how we're contributing to the conversation about sea level rise and producing results that can actually be used to help our coastal communities.
Are there any other questions from reporters in the room? Yeah, sure.
So thank you. I think the economic question of this is huge, and that's where we see in the last week or last few weeks articles nationally about the fact that people are no longer investing in coastal properties as much as they used to. But at the same time, we hear this morning that our president-elect doesn't believe in climate change, thus presumably doesn't believe in sea level rise. So when you show an example from Bangladesh, which is awesome, which is a plan up to 2100, there's a real understanding there of an impact on their country from this rising sea level. And my question to you is, how can we demonstrate that? Because science is great and facts are great, but some people don't pay attention to those. So how can we bring this story of the impact today, not 10 years from now, not in 2100, but how can we as scientists reach this message to our politicians and have a similar type of long-term plan like they do in Bangladesh?
Well, I think events speak. I mean, you know, Hurricane Katrina, Sandy, and events will speak in the future. So, I mean, I believe this is a really important issue, so whatever anybody might say about the issue, events are going to demonstrate the importance of it. And you've also mentioned the fact that maybe property prices, there's actually a market response now to information. I mean, that was interesting. I'm not really aware of that, but it's a sort of rational response to the issue of sea level rise, and also if you want to bequeath some of your investment to the long term, whether you're just buying it for the short term for the view. I mean, some places in the UK, I mean, where we have massive erosion, people buy properties and essentially accept the fact that they will not bequeath that to their children. They are buying something for their retirement, so they're buying something for the short term rather than buying for the long term. So those are all signals that this is pretty important, and I imagine that will lead to a societal response. Quite how, I'm not sure, but I think those are pretty large forces you're describing.
If you're going to add something of a different dimension there, of course, we just talk about the human impacts and how people see this change, but just to look at the Navy bases in the US, there's a lot of our tax dollars being spent already in preparation of sea level rise. And so our government is very well aware of this fact taking place. And we're talking serious amounts of money because the installations are very large. And so it's not a message just completely not reaching it. It seems that it's reaching different people in different ways. But for a long time, sea level rise had already been researched by the Navy. And they knew a lot about this and acting on it. And so I think it's not as draconian that nobody pays attention. Constituents are paying attention. Mayors of coastal cities have alerted this for a long time. Miami is putting all kinds of activities in place. All this is being done with dollars that are tax dollars. So I think it is not that nobody is listening, it's simply that the news that nobody is listening seems to get a bit more attention than it should.
Are there any other questions from reporters in the room? Any other questions on the chat? No? Okay, thank you. That concludes our press conference. Thank you very much. And that concludes our press conferences for today. We'll see you back here tomorrow morning at 8:30 for New Obstacles for Syrian Refugees. Thank you.